Welcome to this explainer. When you glance at the calendar hanging on your wall, or maybe just tap the app on your phone, it's so easy to just see a basic grid of numbers. But we really need to reframe that entirely. The calendar isn't just a piece of paper or a digital widget. It is arguably one of the most brilliant foundational pieces of human technology ever created. It's literally the ultimate operating system for human life. And just like any software we use today, it required constant updates, patches, and bug fixes to keep our civilizations perfectly synced with the universe around us. Think about it for a second. Imagine waking up in a completely unstructured world with absolutely no concept of the date. How did we all look around across vastly different continents and cultures and actually agree on what today is? This was the absolute core problem our ancestors had to solve. Because without a shared system of time, there's no large-scale agriculture, no coordinated trade, and honestly, no complex society at all. They had to figure out a way to measure time and organize life completely from scratch.
Okay, let's dive into this. Version 1.0, reading the natural clocks.
You see, early humans didn't exactly have atomic clocks or satellite data, right? They had to rely entirely on what was visibly right in front of them. And luckily, the universe had already provided three massive, distinct natural clocks. A day is simply the Earth's rotation. A month was originally derived from tracking the repeating phases of the moon, and a year tracks the Earth's complete movement around the sun. Every single early civilization looked up at these three natural cycles and tried to weave them together into a single cohesive timeline to build their very first operating systems.
Which brings us to Section 2, the fork in the code, lunar versus solar systems.
So as civilizations, specifically the ancient Egyptians and the Mesopotamians, grew more complex, they ran into a major glitch. They realized these three natural clocks don't actually align perfectly. You just can't neatly divide a solar year by a lunar month. This led to a massive fork in the calendar code, representing two entirely different approaches. The Mesopotamians really leaned into the night sky, using a strictly lunar calendar, based entirely on tracking the moon's phases. But right next door, the ancient Egyptians took a totally different route. They coded a solar calendar, prioritizing the sun over the moon. And they did this for a very practical reason. The Egyptians' solar calendar was naturally much more accurate for tracking physical seasons, which was an absolute necessity for timing their vital farming and agricultural cycles. Here's where the math gets fascinating. If you rely strictly on the moon like the Mesopotamians did, you end up with exactly 354 days in a year. This specific number is absolutely crucial. It represents a pure lunar year, and it has a massive, enduring legacy. Even today, concurrent systems like the Islamic calendar still use this 354-day lunar structure, which beautifully dictates the timing for vital cultural and religious festivals like Ramadan. But then we have 365. When you contrast this right up against the 354 days of a lunar system, you immediately see the mathematical discrepancy. This is the timeline of the sun, championed by the ancient Egyptians, and it tracks the true seasonal cycle of the Earth. If you try to run a farming society on a 354-day calendar, well, your harvest dates will drift 11 days earlier every single year compared to the actual weather. It's a huge problem. Next up, Section 3, patching the bugs, fixing the Roman calendar.
Matching the math to the weather was critical, but let's be real, not everyone got it right on the first try. Over in the Roman Empire, a super clunky early system resulted in some major systemic glitches that required serious developer intervention. The early Roman calendar was honestly a bit of a chaotic mess. Initially, they tried running the whole year on only 10 months. Obviously, the math there was wildly off. It was just a frantic, duct tape kind of patch that barely held together, so they eventually had to expand it to 12 months just to try and cover the gap. But even with 12 months, their math just wasn't precise enough. Which leads to a terrifying question for an ancient society. What happens when the seasons actually shift? If your calendar tells you it's time to plant your crops, but your calendar is mathematically out of sync with nature, well, the physical weather won't match your schedule. You risk total farming failure. And for an empire the size of Rome, that literally means starvation. The stakes for getting this software right were absolutely life or death. And this brilliantly illustrates exactly why a massive systemic overhaul was needed. We can trace the logic straight from ancient Egypt's early solar observations, right through those frantic early fixes in Rome, all the way to 45 BCE, when Julius Caesar steps in to deploy a massive software update for the entire Roman world. This monumental update was the Julian calendar. Caesar realized the year was slightly longer than exactly 365 days. So he mandated a 365-day year, but crucially, and here's the genius part, he introduced a leap year every 4 years to absorb that extra time. This patch was vastly more accurate than the older broken Roman systems, and it successfully kept the massive Roman Empire in sync with the seasons for centuries.
Moving on to Section 4, the ultimate patch, the modern Gregorian update. But here's the wild part about human innovation. Even Caesar's brilliant code had a bug. It was essentially a slow memory leak, a tiny mathematical discrepancy that no one really noticed at first, but it compounded relentlessly over a millennium. Which raises a pretty big question. Why fix a calendar that seemingly worked fine for 1,500 years? If the Julian calendar synced the Roman Empire and survived the entire Middle Ages, why touch the underlying code at all? Well, because of the math. The Julian calendar's leap year rule was just slightly too generous. Those small mathematical errors meant the calendar year was a few minutes longer than the actual solar year. Now, a few minutes doesn't sound like much, right? But over 1,500 years, those minutes added up to days. The physical seasons were slowly drifting away from their recorded calendar dates. If left completely unchecked, eventually you'd have snow falling in July. Let's move to and see how this builds to our modern day. From the Julian launch in 45 BCE, through centuries of silently shifting seasons, the urgency finally reached a breaking point. So in 1582, Pope Gregory XIII stepped up to issue the ultimate system patch. This patch is the Gregorian calendar. It kept the 365 days, but it introduced a highly improved, mathematically rigorous leap year rule. To fix the slight drift, they made it so century years aren't leap years unless they are divisible by 400. That incredibly precise mathematical adjustment is exactly what keeps our modern world perfectly locked in sync with the sun today. Section 5. Concurrent Operating Systems. Cultural Calendars. So, the crucial point is that while the Gregorian system solved the global synchronization issue, it is definitely not the only software running today. Humanity actually thrives on a rich diversity of timekeeping to honor our history and heritage. Take India, for example. It brilliantly runs concurrent operating systems. They utilize the Hindi calendar, which masterfully combines both lunar and solar tracking, right alongside the national Saka calendar. These systems run in perfectly elegant parallel with the global Gregorian calendar to accurately and beautifully dictate the timing of vital cultural and religious festivals like Diwali and Ugadi. Now, what's really interesting about this slide is how it totally summarizes our journey. From our ancestors simply staring up at the moon, we've evolved incredibly highly accurate synchronized systems. The calendar gives us the power to seamlessly plan our daily lives, gather together to celebrate culturally specific festivals, and flawlessly track the seasons and years without ever drifting out of sync with nature. It really is a triumph of human observation and mathematics. But, it does leave us with one massive looming question. We've spent thousands of years perfectly calibrating our code to Earth-specific sun and moon. So, as we look to the future, how will humanity track time when we settle on other planets with completely different orbits and multiple moons? Are we going to be synced to Mars time? It looks like we might need to start working on version 3.0. Thanks for joining me on this explainer, and I'll see you next time.